So let's balance half equations. We will look at the two methods, okay, depending on the type of half equation that we have to balance. Okay, so first of all, the type of exercise that we might get and why we need to write half equations. So half equations, remember that they show what happened to one element only. So manganese in this case, if it's reduced or oxidized, so what happens in terms of electron and electron transfer. Okay, so there are different ways to get to do an half equation, but we can always follow some steps. So in this first method, we can call it balance the charges, because we want we don't need to work out the oxidation number. And this method, I think it's useful when we have something like manganese oxide, okay, which is a polyatomic ion. So in the half equation, we write it as a polyatomic ion. But it's not straightforward to find the oxidation number, right? Because overall the compound has charges, then there are oxygen present. It's just a bit more complicated. So I would say this, when we have polyatomic ions, we can use half equations. We can balance the charges in order to balance a half equation. Okay, so as we can see in this first one, this is the unbalanced half equation. The first thing we need to do is balance the elements. Okay, so the elements of focus, so manganese, it's balanced, so that's okay. But to balance oxygen, normally is what is unbalanced, because polyatomic ions, they contain oxygen most of the time, so that would be the one to balance. We add water on the opposite side to balance the oxygen. So let me see if I can draw. Yeah. So manganese oxide to manganese 2+. We need to add 4 waters so that we have 4 oxygens on both sides. These, of course, unbalance another element, the hydrogen. So to balance that, we add H+ on the opposite side. In this case, we would add 8 H+ on this side. Okay. Then it's not straightforward to see how the electrons have been transferred. So it's not straightforward to see this oxidation and reduction if we look at the definition in terms of electrons. So what we could do is just balance the charges, yeah, by adding electrons. So we want the left and the right hand side to be the same charge. What I mean is that, so the product side, it has manganese 2+ and water, it's neutral. So overall, the product have a 2+ charge. The manganese oxide and the hydrogen ion, overall, they would have a 7+ charge, because we have 8 H+, so H+, and 1-, so we make 7+. What we need to do is balance those two charges, but we can only add electrons. Okay, so to make it both 2+, we would add 5 electrons on the left-hand side. By adding 5 electrons, this becomes 2+, and this, as you can see, is the same. Yeah, so that's what we mean by balance the charges by adding electrons. And in this case, we can see, oh, great, has been reduced, manganese. If you're not asked the oxidation number, actually, we don't even need it because it's given here. So theoretically, we could work out that there are 5 electrons that have been transferred. However, sometimes we needed to balance the element itself, so you know that there are not 5 electrons, but there would be more. So it can just be a bit more complicated. So I think balancing the charges is always the easiest method, or it could be a way to double check that you worked out the correct oxidation number or the correct transfer of electrons. So that's the first method. The second method, we can just look at the electron transfer. So it's a lot more straightforward, and we would see clearly that like what happened to the elements. And I think it's useful, this method, to look when we have elements on their own,